Okay, we're on section 1-3 now, and we are looking at function notation on this, and basically looking at, first of all, a symbol here, f and then a parenthesis, x and a parenthesis, and that's commonly called f of x. This notation is attributed to Leonard Euler, not Euler, but Euler, okay? Looks like Euler. So in 1770, Euler wrote what is considered the most influential algebra book of all time, Complete Introduction to Algebra. In honor of him, f of x is also called Euler notation. When writing a function notation, what is written in the parentheses is called the argument of the notation. The result is called the value. So in this first example, we have a function called t, and the input or the argument of that function, c, okay, equals 1.8c plus 32. It says evaluate t for 20. So if I were to take that 20, I just need to insert it for c. So that means 1.8 times 20 plus 32. If I actually go through and calculate that, I end up with 36 plus 32 equals 60. I'm going to pause for a minute, and I'm going to have you guys do example 1b on your own. Yes?
That's 68.
Oh, 68. Yep, you got me. Thank you. Ugh, that's what happens when I'm in a hurry. Okay, there you go. 68. I'm going to pause. So you should have gotten, I'm going to get my arrow button, this. 5/9 times 86 minus 32. 86 minus 32 is 54. 54 divided by 9 is 6. 6 times 5 is 30. All right? All right, moving on. Mapping notations. Mapping notations use a colon and an arrow. The function from example 1a can be written in the mapping notation as follows. T colon c, arrow 1.8c plus 32. It means the exact same thing as how it was written before. So these two can really be interchanged. I could say T of C like it was before. It's just a different way of writing it. Okay? So this is read, the function maps f, the function f maps c onto 1.8c plus 32. So for f of 20 equals 68 in mapping notation, we write f colon 20 maps to 68. Here we have a function f where x maps to the square root of f to 5 squared minus x squared. We want to evaluate f of 3 and then f of r minus f of 3. Scroll down? Sure. That help? Okay. So here, first of all, what I did was solve for f of 3. So notice that we have 5 squared minus 3 squared. And if you go through and solve that, you end up with 4. The next part I wanted to find was f of r. I'm just replacing the x with an r. There's not really anything I can do with that, is there? No. So then if I wanted to find f of r minus f of 3, I'm really just taking this minus this and setting it together. So on this last example, this is what you should end up as your final.